Let's just redefine what we have discussed in the previous video. In the previous video, we said that math.random function is a Node.js or browser part or functions. It's actually part of JavaScript as well, as we have discussed with here, math here. So math is the parent module of random method. So if you look at the standard object section in the image, you'll see math listed. So why the confusion? In the previous message, we were grouping things to show what works everywhere versus what only works in specific places. Map function and math.random function. These are ECMA script, core JavaScript. They work in your Chrome browser. They work in Node.js and they work inside your React components. DOM APIs like document. These are browser features. So think about this as again a language. So this could work in different cities. DOM APIs like document. These are browser features. FSR process. These are Node.js features. A simple test. If you ever want to know if something is core JavaScript or an environment API, try these. First, open Chrome, right click, hit inspect and go to the console, type math.random and hit enter. And then open your computer's terminal, type node, then type math.random and hit enter. It works because it works in both cities, browser and node. It's part of the language, JavaScript. In the context of your project, when you are writing your hacker-stories app, you use map to loop through your list of stories. You could use math.random function if you wanted to generate a random ID for a new story. But you cannot use fs.read file to save your stories to a text file on your hard drive because React runs in the browser city, which doesn't have the full access permission shown in your image. So basically, later we will discuss or in the future video React basics, which discuss components. So there is a server components in React that can access this like fs.read file, but for like client side component such as the normal function and class components and let's see what's the component. The create class, mixin component, higher order components, and then async components, and then mixin. Those components we will discuss in the future video, which is the basic of React. But basically, only a sync server can access this environment-specific API. Now let's continue with managing extrinsic states. Next, we need to store the states that were removed from the book object somewhere. Luckily, a manager, which we'll be defining as a singleton, can be used to encapsulate them. Combinations of a book object and library member whose check it out will be called book record. So earlier we discussed the the data relevant to the book, which is the intrinsic state. Earlier we discussed how we create its own object while the checkout data check member is considered extrinsic. So those checkout now will be managed in this. So as you can see, we create a flyweight or the concrete flyweight using those by managing those intrinsic state. So remember, concrete flyweight actually implements the flyweight interface and stores the intrinsic states. And then a flyweight corresponds to an interface through which flyweights are able to receive and act on extrinsic states. So, the concrete flyweight implements the flyweight interface, but the flyweight is just an interface that able to receive and act on extrinsic states, while the concrete flyweight implements the flyweight interface, which is this interface. It implements that and store the intrinsic state. So it doesn't just implement the flyweight that are able to receive and act on extrinsic state, which is this, but it also manage the intrinsic state. Now the factory, flyweight factory manage flyweight objects and creates them too. So if concrete flyweight implements this interface, and then flyweight factory manages the flyweight objects or the instantiation of this concrete flyweight, therefore they all came from flyweight factory, as we can see here. So we have create book, book factory, create book title, const existing book equal and then const book equal new book. So here we instantiate this book, which implements the interface for the flyweight, and then we return a book. So here now when managing the extrinsic states, we need to store the states that were removed from the book object somewhere. Luckily, a manager, which we'll be defining as a singleton. So in order to manage extrinsic state, we need to use a singleton. So as we have noticed here, we are now discussing multiple patterns at once: flyweight, factory, singleton, to encapsulate them. So it also used like class, kind of like class pattern of the modern ES modules, and it also used the module that we have discussed in the previous video. Basically everything kind of like coming together. It also used the constructor, right? Because inside the class factory, you have this create book, which acts as a constructor here, new book, and it also has prototype. Now combinations of a book object and the library member was check it out will be called book record. So the combination of this book object and the library member, which library member is related to the manager or a singleton, was check it out will be called book record. So our manager will be storing both and will include checkout related logic. So now we have checkout date, comma checkout member, aside from just the book object like the ID title, we strip out during our flyweight optimization of the book class. So here, just like with the factory, we start with const book record database and an empty object. So in the factory, we start with const before we place a class. So here, add book record, checkout date. The result of these changes is that all of the data extracted from the book class is now being stored in an attribute of the book manager singleton. So an advantage is that all of this data is now extracted into and now being stored in an attribute of book manager, which is singleton or book database, something considerably more efficient than the large number of objects we were previously using. So instead of like this large number of objects, creating those, we're basically stripping those shared that we have in a book object, as well as the extrinsic state, the checkout date, and then combining those. And then in factory, of course, it will reference that concrete flyweight. And here we include both the book or the intrinsic state and the intrinsic state and the extrinsic state, for us to be able to manage large number of objects while at the same time keeping its locality, which is the extrinsic state. So methods related to book checkouts are also now based here, as they deal with extrinsic rather than intrinsic data. This process adds a little complexity to our final solution. However, it's a minor concern compared to the performance issues that we have tackled. Data-wise, if we have 30 copies of the same book, we're not now storing it only once. Also, every function takes up memory. So before, we're storing, if we have 30 copies of the same book, we will now store it only once. Also, every function takes up memory. With the flyweight pattern, these functions exist in one place on the manager and not on every object, thus saving on memory use. For the unoptimized version of flyweight mentioned previously, we store just a link to the function object as we use the book constructor's prototype. So as you can see, we use a prototype here and a constructor. So the unoptimized version of the initial flyweight we store just a link to the function object as we use the book constructor's prototype, which is this book is our constructor prototype. Still, if we implemented it another way, functions will be created for every book instance. So here we create a class book record manager, and we create a function add book record with the book specifics and extrinsic state checkout, and then we create const book factory, which is initiating this book factory, the capital book factory, and then next line const book equal book factory that create book. So this create book are the methods inside the book factory with the title, etc., and then book record database, which we initiate here in book record manager singleton id with the parameter id equal checkout member checkout date. Then here in book record database we initiate the extrinsic state and the book we just created. So the book has those shared objects. Now update checkout status, so we create an update checkout. So add book record, and then now update checkout with the book ID, new status, checkout date, checkout member. And then const record equal book record database parameter book ID, then record that availability equal new status, so etc. And then extend checkout, we create extend checkout, and this is the implementation, and then is past due. So basically it's just the implementation of the book record manager. Let's find out where the book ID here this that id equals the book id, so it's in the update checkout status of our initial book class to represent each book as follows before any optimization. So that's the initial unoptimized. We use a book ID, but where did we use it here? I see. So here we have like an extend check out period with the parameter book ID. So this is the book ID. We define that as a parameter in extend checkout. So next, the flyweight patterns and DOM. The DOM supports two approaches that allow objects to detect events, either top-down, event capture, or bottom-up, event bubbling. So if it's from top to down, which is like, I think that's how React states or props are being managed. Just me. Yeah. So basically, for React, it use a pattern where it manage its data from top to bottom. So you can think of that as a top down, which is the event capture. So that kind of like, how would you remember how the flyweight and DOM works? Because in React, so for bottom up event bubbling, we don't use that as much, or it's not effective organization of like JavaScript, especially in the front end. But still, we will discuss it here. In event capture, the event is captured by the outermost element and propagated to the innermost element. In event bubbling, the event is captured and given to the innermost element and then propagated to the outer elements. So Gary Chisholm wrote one of the best metaphors for describing flyweights in this context. And it goes a little like this. Try to think of flyweight in terms of a pond. A fish opens its mouth, the event. Bubbles rise to the surface, the bubbling. A fly sitting on top flies away when the bubble reaches the surface, the action. In this example, we can easily transpose the fish opening its mouth to a button being clicked, the bubbles as the bubbling effect, and the fly flying away to some function being run. Bubbling was introduced to handle situation in which a single event, a click, may be handled by multiple event handlers defined at different levels of DOM hierarchy. Where this happen, event bubbling executes event handlers defined for specific elements at lowest level possible. So here it's describing this second type, which is the bottom up. From there on, the event bubbles up to containing elements before going to those even higher up. Flyweights can be used to further tweak the event bubbling process, as we'll see in example, centralized event handling. So we can tweak this DOM event bubbling or bottom-up approach using the flyweight in centralized event handling, which we will discuss later. So centralized event handling, the flyweight DOM example, is based on event bubbling, not event capture. Okay, so now I'll show you why, and this will connect to React and your LiveKit UI. First, what really happens when you click a button? When you click an element in the browser, something surprising happens. The event does not just occur on that button, it travels through a path inside the DOM tree. Example HTML. So div ID equals to attribute up, and then inside of div is UL, and then with the attribute ID equal menu. Inside UL is LI, and then inside LI is a button with an ID at attribute equal join. So the browser internally sees a tree. So you have window, document, HTML, body, hashtag up, hashtag menu, and then LI. So the reason why up is because that's the div, and the hashtag menu is the ID, the UL, and then LI, and then button, and then hashtag join. So when you click the button, the event moves in three phases. First, capture phase, top down. Second, target phase at the bottom. Third, bubble phase, bottom up. So it starts with top down. First, capture, outer to inner. So we have document to body, to div, to UL, to LI, to button. The event is traveling toward the button. Almost nobody uses this phase in real apps. Second target, the button receives the click. Third, bubbling, inner to outer. This is the event bubbling. Now the important one. So we have button to LI, to UL, to div, to body, to document. The event climbs back up the tree. This is the reason why flyweight works. Why flyweight uses bubbling? The book says attach a flyweight to the top of our container. Meaning instead of doing this, so we will attach it to the top or in the parent, which is in the document. So instead of doing this like in the bottom document that query selector parameter button dot for each, then bottom arrow function button that add event listener parameter click comma handle click, you do this document that get element by ID in menu. So it's not actually document in the UL. So we put that in menu and then add event listener parameter click comma handle click. You attach one handler to the parent. But the button is still clickable. Why? Because the click bubble ups to the parent. So the bottom at the bottom still clickable because the click bubbles up to the parent, or in this case the UL. So the parent receives the event and can expect event that target, which tell which child actually trigger it. So the parent becomes a central dispatcher. This is the flyweight. Why is this called flyweight? Memory reason. So that is the central dispatcher in glance. So why is this flyweight? It's because for memory reason. Imagine 1000 chat messages in your LiveKit UI. If you attach a click listener to each, so let's say you have like 1000 chat message. If you attach like each listener to that kind of like button, so remember whenever like we're creating component, we're instantiating instance. So think of this chat message as an instance that we will attach to our UI whenever a chat message is instantiated. So if that happens, we have 1000 DOM elements, 1000 functions in memory, 1000 closures, 1000 references. This is actually becomes expensive. Flyweight instead, one listener, shared behavior, dynamic target detection. So we have one listener in UL, it's a shared behavior and the dynamic target detection. So you're sharing behavior across main objects. That is literally the definition of flyweight. So real example, your LiveKit app. Suppose each participant has a mute button. Instead of participants that for each p arrow function that and then p dot button dot on click equal mute user p dot id then closing, you do room container dot on click equal e arrow function const btn equal e dot target dot closes dot mute dash button, then if not btn return so instead of participants that for each p, then p dot button dot on click, then mute user p dot id, we have room container dot on click arrow function const btn equal d dot target dot closest dot mute dash btn, if not btn return, then next line const id equal btn the dataset dot user id, next line mute user parameter id closing. Now you can add or remove participants dynamically. No rebinding needed. Memory stays low. This is exactly why React internally uses this idea. Important revelation, React also uses bubbling. This is a big one. React does not attach events to every button. React attaches a single event listener to the room DOM container. So this is actually how React do that internally. It attached the event listener to the root DOM instead of the actual bottom. Yes, literally flyweight plus centralized event handling. Then React internally dispatches like real DOM event to React's synthetic event to component handler. So when you write less than button, then on click equal open semi-curly bracket join room closing, and then greater than tag join, and then closing tags button. So basically we have on click with a JavaScript like join room variable. React is actually doing, so this is a declarative way to use it in React. Root listener receives click, figure out which component create that node, and then calls your function on that component that created that node. You were already using Flyweight without realizing it. So what is event capture used for? Rare cases. So the top to bottom are actually rare case to be used in React. But what I'm saying earlier is that the top to bottom principle is actually how data flows from database to your front end. So it is still being used in much higher like abstraction rather than in the UI component, because now we're specifically discussing about the UI component and how it bubbles up from the DOM or the event handler parent DOM API to its child element. So rare cases, we can use event capture in specifically UI for analytics tracking, intercepting before children, blocking behavior early. So if you want to intercept before the children, or like you want to be in those grandchildren, or you want to block those parent or something, or blocking behavior, you would use this event capture. You can use that using document dot event listener parameter click comma handler comma true. So you can use that in React as well, but it's not the declarative way of using React, it's an imperative. So the true equal capture phase, but Flyweight centralized handling relies on bubbling because the parent needs the child to trigger the event first. So the true is the capture phase or the top to bottom phase. But Flyweight centralized handling relies on bubbling or bottom to up because the parent needs the child to trigger the event first. So in Flyweight, though you're using bottom to up, the child still need to trigger the event first for it to bubble up to the parent. So why the pan metaphor actually matter? Fish equal child element bottom, bubble rising equal event bubbling. So fish is the child element, which is the bottom. The bubble rising is the event bubbling. Fly reaching equal parent container handler. So the parent does not cause the event. It observes it after the fact. That's why this also conceptually close to the observer pattern, and why these patterns stop overlapping in the UI systems. So you can, since it's close to the observer pattern, it's actually using multiple patterns at once. Prototype, Flyweight, singleton, factory, constructor, class, Flyweight. So the deeper understanding, you just cross a bridge, big mental bridge. Design patterns are not abstract. They are actually describing how the browser event system behaves in memory at runtime. So this design pattern are actually describing as well. So another layer of it is it's describing the memory at runtime. So Flyweight DOM is equal one shared behavior reacting to many objects via bubbling events. So since JavaScript like is a object or came from many prototype instantiate many object. So this flyweight basically is a pattern in memory that allows you to share that one object reacting to many objects via bubbling events. Because before we discussed how the flyweight is being used in a code not related to the DOM API. Now we're discussing how we're actually applying this pattern with respect to a DOM or parent container and child as a parent element and child element. And this is exactly why modern UI framework exists. Final clean answer: centralized event handling in the flyweight DOM example uses event bubbling because the event starts at the child, travels upward, the parent intercepts and dispatches the logic. So the parent object intercept when it bubbles up and then just dispatches the logic, not capture. So it's the same idea we have discussed with the factory intercepting it, right? Or the book record database that handles the extrinsic and the intrinsic state. And React's event system is essentially a structured implementation of the same idea. So for our first practical example, we have several similar elements in a document with similar behavior executed when a user action like click, mouse, hover is performed against them. Usually when constructing our accordion component, menu, or other list-based widgets, we bind a click event to each link element in the parent container, IAUL, LIA, dot on. So instead of binding the click to multiple elements, we can easily attach a flyweight to the top of our container, which can listen for events coming from below. This can then be handled using logic as simple or complex as required. So as the types of component mentions often have the same repeating markup for each section of an accordion, there's a good chance the behavior of each element click will be pretty similar in relative to similar classes near B. We'll use this information to construct a basic accordion using Flyweight's example in 7.6. So a state manager namespace is used here to encapsulate our flyweight logic. So this state manager, which is here, are the one or the parent element that encapsulate the logic. While jQuery is used to bind the initial click to a container div. So the jQuery is used now to bind the grandchildren to a container div, which is our flyweight logic, the state manager. So an unbind event is first applied to ensure that no other logic on the page attaches similar handles to the container. So an unbind event is first applied to ensure that no other logic on the page attaches similar handles to the containers. So these are the container, our const manager. So an unbind event is first applied. So we use an unbind or we apply an unbind event to make sure there's no similar handles to the container, so that we can make sure that there's no duplicate parent handling all this shared multiple button click. So to establish exactly what child element in the container is clicked, we use a target check. So to establish what child element in that parent container or what child element or button is click, we use a target check. Which provide a reference to the element that was clicked. So that target check provides an so basically we provide a target check which provides a reference to the element that was clicked, so that the parent element can know what was clicked or what child element was clicked. So we use a target check regardless of its parent. We then use this information to handle the click event without actually needing to bind the event to specific children when our page load. So yeah, here the LM, so that's the LM handle click LM. So we use that target to be able to check it without actually binding that to the actual child element. So that's it. And then next video we will discuss behavioral patterns.